Now, we want to refactor this ugly code. Now, if you put aside the duplicated logic, what are the parts that are different here? Well, we have column names and these lambda expressions. These are the parts that are different from one block to another. Now, what is the type of our column names? It's a string. What is the type of these lambda expressions? It's an expression object. So, these lambda expressions, their type is expression of func of vehicle and object. What does this mean? First, let's import the namespaces. So using system.link.expressions. All right, so whenever we write a lambda expression, like v goes to v dot something, like contact name, this represents an anonymous function. We can store the result in a func object, a function. So a function of vehicle and string, we can set it to this lambda expression, okay? We can also store this as expression of func, of vehicle, and string. So with this, we're just representing an expression. And if you look at the signature of link extension methods, like order by, where, and so on, you can see all these methods get an expression. With these expressions, we can build an expression tree. So we can represent some logic using an expression tree. Then at runtime, link provider is going to look at this expression tree and convert this logic into SQL statements. Now here, I would like to change string to object so we can reference any properties of the vehicle, not just string properties. Okay? So let's delete this. What we need here is a mapping between a string and an expression. So we have this string here, like make, and we want to map it to an expression like this. So I'm going to declare a dictionary. So a dictionary is used for mapping. The keys are strings, and the values are expressions. Expression of func, of vehicle, and object. Okay? And let's call this columns map. Now let's initialize this to a new dictionary of string and expression of func, of vehicle, and object. So let's delete these two lines. Okay, looks like I missed an angle bracket here. All right. Now this dictionary declaration is a little bit too noisy. We have repeated it twice. So I'm going to change the first one to var. That's cleaner. Now in this dictionary, we can add key value pairs like this. So columns map dot add. Here you pass a string like make, and then an expression like v goes to v dot model dot make dot name. And then we can repeat this a few times, or we can use a cleaner syntax that comes in C#6. So let's delete these. Before semicolon, I'm going to use the object initialization syntax. Now for each key value pair, I'm going to use square brackets, make, equals, and here we set the value, which is an expression. V goes to v dot model dot make dot name. Now one more time. So model, we set it to v goes to v dot model dot name, and we add the other columns like this. Now with these mappings, we can rewrite this duplicated logic like this. If query object that is sort ascending, we're going to set this query to query.order by. Now here we need an expression. We can get this expression from our dictionary, right? So columns map, we specify the key, which is the name of the column. So query object that sort by. Now otherwise, if the query is not ascending, I'm going to copy this and change the second one to order by descending, right? And finally, I'm going to get rid of all these ugly statements. So this is the end result. Every time we want to add a new column, we simply add it to our dictionary, and this logic is reusable for various column names. However, we are not finished with our refactoring. There is more to do to clean up this code, and that's the topic for the next lecture.